NCERT Class 11, Chapter 10, Mechanical Properties of Fluids, question number 10.31. It has given us a relation of the variation of density with height, and we are required to obtain this law assuming that the temperature remains constant and the value of G also remains constant. Okay, then for the first part A, let us suppose this is the ground and we are observing at a height y. Now let us say at the ground level, that is where the y is 0, the pressure is P naught and density is rho naught, and at a height y above ground, let the pressure be P and density be rho. And with further change of y, that is dy, let us say the pressure decreases by dP and the density decreases by d rho. Now I can write that the change of pressure with height across these 2 points, that is this and this, dP can be written as minus of rho g into dy. But we have pressure is equal to rho RT by M. And from here I can write dP is equal to RT by M into d rho. Because temperature has been assumed as constant, molar mass is constant, our gas constant is constant. So if I substitute in that equation, what I get from here is RT by M into d rho is equal to minus rho g into dy, and this gives us d rho by rho is equal to minus of mg by RT into dy. And if we integrate this, at y0 density is rho naught and height y density is rho, this gives us ln of rho by rho naught is equal to minus of mg by RT into y. And let us write this minus of mg by RT as 1 upon y naught. So this relation becomes this one, and this gives you rho is equal to rho naught e raised to power minus y by y naught. And then as per our relation, this y naught is equal to mg by RT reciprocal, or you can say it is RT by m into g. So this is the variation of density with height. Now for the second part, it says that a helium balloon of volume 1425 meter cube is used to lift a payload of 400 kg. Assume that the balloon maintains constant as it rises. How high does it rise? So I can say as it goes upward, that is because of buoyancy force, and obviously as it goes up, the buoyancy force will decrease because the height density is decreasing with height, and thereby I can say at maximum height the weight will be just balanced by the buoyancy force. Now buoyancy force will be density, that is rho naught e raised to power minus y by y naught into volume, that is 1425 into g, and the weight is 400, that is for payload, into density of helium into volume whole into g. This g gets cancelled. I get rho naught e raised to power minus y by y naught into 1425 is equal to 400 into plus density of helium is 0.18 into volume is 1425, and this gives us e raised to power y upon y naught is equal to rho naught into 1425 upon, and this 400 plus 0.18 into 1425, this comes out to be 656.6, divided by 656.6. Rho naught has been given as 1.25. So e raised to power y upon y naught gives you 2.71. So this is 2.71 raised to power y by y naught is equal to 2.71, and that gives you y is equal to y naught, and that is 8,000 meters. The maximum height to which it will rise will be 8,000 meters.